Okay, so today's lesson is adding and subtracting rational expressions with like denominators. All right, so recall that when you add and subtract fractions, you have to have like denominators. Okay, you can't forget how to add and subtract fractions. If we asked you to add something like 5/8 plus 2/8, well, we're just talking about eighths, and 5 plus 2 is 7, right? That'd be 7/8. If we said to you, can you subtract 5/8 and 2/8? Well, then you would do 5 minus 2, which is just 3 over 8. Okay, so don't forget that you already know how to add and subtract fractions, and the denominators are alike. So now when we start making the denominators become polynomials or just monomials, algebraic expressions, no big deal. Okay, so when you add and subtract rational expressions with like denominators, add or subtract the numerators, just like you normally do, right? You're going to write that answer over the common denominator, just like you normally do. If you can, you try to simplify. You might need to factor. You just have to look to see what's left over. All right, so fractions, again, no big deal. Don't treat them like you don't know what you're doing, because you do. Okay, so this first one, like denominators, we've got over 7. So it really becomes, okay, 5x plus 2x all over 7. I've got like terms in my numerator. It's 7x over 7. And I know that 7 divided by itself is just 1. So this final answer is just x. No big deal. Take a look at the next one. 3 over x plus 5 over x. Well, your common denominator is just x. You want to add the numerators if you can. 3 plus 5, you can. 8 over x, nothing can simplify. You're done. Let's take a look at the next one. Common denominators, 3m. So we know we're going to end up with 3m in the denominator. Well, you're subtracting. You can just do 7 minus 4, right? Not a big deal. 7 minus 4, you know that's just 3 over 3m. Well, as it turns out, 3 divided by 3 is just 1. The m is on the bottom. You can't leave the numerator alone. This is your final answer. Some of you guys might want to think about subtraction as keep, change, change, which means you could have done plus, negative, and then it still would become 7 plus negative 4 or 3. Next one, you have common denominators. Your common denominator is just this binomial, I put it in parentheses, x plus 3. Your numerator is 3x plus 9. Those are not like terms. I cannot combine them. But what you should realize is you can factor by GCF in that numerator. I can pull out a 3, be left over with x plus 3, over the common denominator, x plus 3, and guess what? These binomial factors simplify. This final answer is just 3. Let's try another one. Common denominator? Absolutely. And I'm going to put it in parentheses because it's a binomial factor. My numerator, I've got x plus 1 plus 5x plus 3. Well, there are like terms up top. My like terms are x's for 6x, 1 and 3 plus 4 over this binomial factor. Can you factor the top? You sure can. I can pull out a 2 with 3x plus 2 left over that other 3x plus 2, and guess what? These binomial pairs cancel each other out. This final answer is just 2. Let's take a look at number 6. Number 6, common denominator. It's this factor of x minus 1. My numerator, and here's where I'm going to do something a little bit different, but well, not really. It is subtraction. I'm going to keep, change, change, which means I'm going to change subtraction to addition. This x becomes negative. This 1 becomes negative. So my numerator looks like this. I've got x squared plus x plus negative x and negative 1, right? That's essentially what happened. So now when I take a look at my numerator, I don't have any other x squareds. That just comes over as is. These guys, x plus negative x, cancel out, and I've got the minus 1 all over the x minus 1. You should look up top and say, wait a second, that looks like a dots problem. They're both perfect squares. I can factor the numerator x minus 1, x plus 1. My common denominator just gets carried over from one fraction to the next. And now I can actually cancel out those binomial factors. Your final answer, x plus 1. Let's take a look at one more. This is subtraction again, and I'm going to realize that, you know what, I'm going to keep change all. So I'm going to add, make that a negative, make that a positive. My denominator is a trinomial. Looks like I'm going to be able to factor it, but I'm going to keep it like this at first. My numerator, if I combine like terms, 3y, negative y, 2y, don't forget that turned into a plus, so plus 10. I can factor everything, GCF up top, 2, y plus 5 left over. On the bottom, I've got an IM, y plus 3, y plus 5. Well, I realize that these two binomial factors can cancel each other out with a final answer as 2 over y plus 3. Okay, so when you add fraction with common denominator, add the numerators or subtract the numerators, whatever it asks you to do, all over the common denominator. And if you can factor even more, you do so. Good luck on the homework.